Hello students, I've seen many of you struggling with circle theorems. So today's video is about circle theorem. Let's master all of them in a few minutes. So I'll start with the first circle theorem. And yeah, I wanted to mention that I had given one circle theorem statement and then the general form as well as two examples of each for a better understanding. Let's start with the first one. Angle at the center of a circle is twice the angle at the circumference. So it's basic. When you see something like a arrow, okay, or an arrowhead, whenever you see an arrowhead, so the point on the circumference here will be x, then at the center in the same segment will be double of it. Say example 1, if it is 44, so here it will be double of it, 88 degrees. Example number 2, if the center is 76 or angle at the center is 76 degrees, so angle over here at the circumference will be half of 76, that's 38. It's very simple. And the hint is it looks like an arrowhead. That's it. Next one, angle in the same segment are equal. It is also known as bow tie case, which looks like a bow tie on the suit. So see here, all the angles in the same segment in the sense you can see they all start at the same point and at the same point. Segment of a circle is something like this. This is one segment, the top one is major, the bottom one is minor segment. So the starting and end point will be same and all the angles forming over here will be just the same, and it appears to be a bow tie case. You can see in both the examples it appears to be a bow tie. Look at the angle. If here it says 36 degrees, this will also be 36 degrees. Straight away you can write it. If you see on the other side here, if this angle is 52 degrees, you don't need to measure it, you don't need to do any calculation. They are in the same segment, appears to be a bow tie. This will also be of 52 degrees. Straight away you can do this. Let's go to the third one. Angle in a semicircle is a right angle. Always angle in the semicircle. Whenever you see, say let's have a look at it. This is a semicircle. So angle over here will always be 90. This part will always be 90. This part will always be 90. Without any calculation, you can answer this. So if the question is about this angle, you can straight away say that it is 180 minus, you just have to see, this is 90 and this is 40. So 90 plus 40, that's 130. So 50 degrees. So this angle is nothing but 50 degrees. If here it's 30, this is definitely 90. So if there's a question about this angle, we can straight away say 180 minus 90 plus 30, that's 120. So 180 minus 120, it's going to be 60 degrees. So this angle is 60 degrees. This is how we work out third one. Then we'll go to the fourth theorem. Fourth theorem is about the opposite angles of a cyclic quadrilateral add up to 180. Look at the opposite angles. I have marked it with the green. These two are opposite ones and these two are opposite ones. Have a look at it. The opposite ones will add up to 180. So if this is 120, this will be 60, makes it a total of 180. If this is 80 degrees, this is 100 degrees. Total of 180. The opposite angles make 180. If this is 50, this is 130 degrees. This is 45, this is 135 degrees. Opposite angle makes a 180. Next theorem is about angle between a tangent and a radius is always a right angle. You can have a look at it. Whenever a tangent and a radius intersects, they form a right angle or 90 degrees. Look at here, here, here. How many of a radius or radii intersecting any of the tangent at a point will always be 90 degrees. You just remember that. Whenever you see a T-like structure, that's 90 degrees. Then the next one, the length of two tangents drawn from an external point to a circle are equal. From outside, any point, external point of circle, if you measure two tangents up to this particular point where they are intersecting or they are touching the circle, they will always be equal. So for an example, if this is 5 centimeter long, this will be 5 centimeter long. If this is 7 centimeter long, this will also be 7 centimeter long. Irrespective of, even if you make it even longer, that doesn't make any difference because we consider it only till this point. Then the last theorem is the angle between a tangent, which is basically known to be the alternate segment theorem. The angle between a tangent and a chord through the point of contact is equal to the angle in the alternate or opposite segment. Look at it. Here if it is x, exact opposite to this chord, there is an angle. This angle is same as this. If I write this angle as y, exact opposite to this chord, this angle will be y. So let's see first one. If this is 84 over here, exact opposite to this chord, this is 84 degrees. Here, look at it, this is 72 degrees. Okay, so this time the angle is not between tangent and a chord. We have to assume that exact opposite to this is the chord, and between the chord and a tangent, this angle will be 72. They can ask you both the ways. Okay, so we have to be ready with whatever kind of question, whatever kind of trick is there, there in the question. So this is all about the different types of circle theorem. Revise it, and you don't need to sit and memorize it. You can just understand the concept easily.